Good afternoon, everyone. I, Nagma Anjum, Department of ECE, NCET, would like to welcome the speaker of the session, Mr. Ganesha Narayana Swami. Welcome you, sir. I would take this as a pleasure to introduce the speaker of the session, Mr. Ganesha Narayana Swami. He is an open leader in education and senior technical computing solution and research IBM system, client core manager at IBM Bengaluru. He has completed his Bachelor of Engineering in Vivekananda College and did his Master's in Computer Science in Alagappa Chettiar College of Engineering and Technology. He worked as software engineer in Digital Equipment Corporation between 1995 and 1996. He has around 9 years experience as technical lead in cluster system develop, and he's currently working as cluster system development manager. Currently, he is a senior technical computing solution and client core manager. I would now I would like to hand over the session to our speaker, Mr. Ganesh Narayan Swami. Welcome you, sir, once again.
Thank you for the introduction. Good afternoon to all. Actually, I don't know whether where they got my profile, but my profile is a little different. I'm a global worldwide leader for IBM Open Power and Power Enablement.
Okay,
It's
sir.
basically power is actually I've been with IBM for last 25 years, and I have been, working with many customers worldwide, and also industry enablement, and many technology, solutions, which we have been providing through our, the foundation called Open Power Foundation, which was established by IBM, Google, NVIDIA, Mellanox, and Tian during 2013 and 14 timeframe. And now that foundation has become a kind of a 300 plus members foundation, and has got lots of the partners involved. And now our focus is to develop the chip, the processor. That's where even this uh, workshop, the webinar, whatever I'm going to give right now, going to be connected with that. We IBM's the power processor. This has been there with the customer for the last 30 years, and we started with the power one, uh, power two, power three, like that. The versions were there, and now we just released last year power 10 with lots of capabilities where AI kind of feature also implemented as part of that. So the power processor is basically kind of processor with systems. IBM build it, and and like basically deliver it to a lot of enterprise customers, not desktop or PC and all, or a laptop. It's basically enterprise customer where the server class, the servers, a lot of servers, like where banks as well as several other industries need to process the data, the computing power and all, like a lot of things matter there, along with the secured system, secure transaction, the power system, I've been providing and has been engaging with many customers worldwide. We got around 25,000 customers worldwide using that. And the number, and also in the supercomputing world, when you talk about supercomputing, it's called like, the high performance computers. There are a lot of people, do build, the supercomputers like HP, and, the Dell and Lenovo and many other, competitors, partners, we have, who are building supercomputers. But right now, IBM, do have a lot of supercomputers in the top, 10 supercomputers list, top 500 supercomputer list, and in the top 10, we have two supercomputers called Summit and Sierra, number two and number three. You can look up in the internet on that. Summit, Summit, and Sierra, Sierra. These two supercomputers we installed in both Lawrence Livermore National Lab and Oak Ridge National Lab, one in Tennessee, US, and other one California in US. Both are actually, solving lots of mission critical applications. Uh, you know, kind of, the problems, which could be solved by only supercomputer. And we got nearly like a 4,000 systems connected together to process the data, both high performance computing and AI kind of applications, that can process. That's where, like, I just wanted to, start the introduction here. And with that experience, the wealth of experience, in US, many years I worked in US, and also, like, now I have taken up a global role where enable the clients with our technology. When I say about our technology, is actually silicon to the application. What does it mean to you? Silicon to application is basically, we develop processor, we design and develop and manufacture processor, and then we develop, the operating system, and we develop the firmware for that, and we develop the motherboard and the complete, the hierarchy, like, the scale, we do it. And that's why, I call it silicon to the application. And also there are a lot of applications IBM customer use it, from us. And one of them, I would say, like, WebSphere, or many things, data stage, you might have heard about it, ETL tools, many tools. And then even, lately Watson application which we developed, and like that, many things, we do on top of that. But the stack is all completely owned by IBM, from silicon to the application. So what is the purpose of this open power foundation? Is basically, we basically opened up a lot of our technology as part of the foundation, with the help of IBM. And IBM now, there are several things, available for faculties, students to get educated, and developers to get hands on and build your own processor, or build your own, kind of a stack, computing stack. And that's where, I want to, address more here, where, we will be discussing about, you know IoT and AI, right? That's the thing, the AI OT. So let me, first, complete my the journey on that supercomputing build. So, in 2000 time frame, we also built the supercomputers, like called Deep Blue, the one which was playing with that time, the Gary Kasparov, the world chess champion, and IBM did beat that person, for a couple of times. That supercomputer called Deep Blue. In that computer, the storage and computing capacity is very less compared to the one what we have right now, Summit and Sierra. Where there we got, like 16 node, 16 systems together, and built a supercomputer to play with, the Gary Kasparov, for the chess competition. And now Summit and Sierra have been built with 4,000 systems, with superpower NVIDIA NVLink kind of, the GPU system as part of that, and a powerful interconnect that made the complete, the supercomputer to be, to be, uh, to become popular, and also to take a lot of workloads, mission critical applications. Many people have been running with it, and these supercomputers already installed in some of the places in India too. One in CDAC, the others are in IIIT Bangalore, IIT Hyderabad, and many other places, Sastra University, and all these places. The code name for that computer is called AC922. accelerated computing. That's where it's called AC922. So the difference between the one which we built in year 2000 and year 1997 exactly, the Deep Blue, and the one what we built in 2017, the Summit and Sierra, the two key differences are there. You know that's the reason this AI and IoT have become very popular and people want to use it. May know, can this is a kind of the general knowledge which you should have, one should have. I just want to know, like, what would be the main difference between computer which we built in 1997, the computer 5 years back. But anyway, what would be the key difference? Can someone point me out on that so that we can have this session more interactive? That's where the AI and IoT will play a big game there. Can anyone talk? Can anyone respond to my question actually? What would be the difference between the one which we built in 1997, a Deep Blue system, and what we built in 2017, Summit and Sierra? What would be the key things which would have made a big difference? And because of that, the AI and IoT became very popular also because of the two things which is large right now to do that. May know anyone can answer that, or at least if you think your idea thought. So let's make this program interactive. Otherwise, it's not. It's going to be monotonous. So only I'm going to talk, and I'm going to be just talking for for things. But anyway, yeah, somebody
Yeah,
is
is
interested
it
to.
the system configurations and technologies that made the difference?
Yes, system configuration and technology. What is the system configuration and what is the technology? Can you just little expand on that? Thanks for that. Talamal Indu.
Yes. Is the
Yeah,
GPUs that
Indu.
are available now? GPU.
Yes, that's correct. The GPU. What does the GPU do?
We can train a lot of data.
Okay,
on
so
GPU.
we can train a lot of data. That's right. The training means what? It's called computing. So more compute is available right now. There we are talking about 1 gigahertz, or very less number of computing power, including I'm talking about CPU as well as lately the GPU. But now we got super power computing. Like a 200 petaflop of the computing power available in Summit and Sierra. Think about it, 200 petaflop, gigaflop, teraflop, and petaflop. And now the world is looking at right now exaflop too. So 200 petaflop of system computing power available. That means what? Whatever you see here, Hindu mentioned about training the data. There are two things are there in that one only. That's what I wanted to talk about here. Train, when you do the training, that is called compute. You are computing something, then only you can get the things trained. Compute means the operation you need to do, right? A plus B, that is the
Yes.
operation where the computer will go and do the calculation with that. That is called computing. And I'm talking about only simple the A plus B, but that could be thousands of A and thousands of B and thousands of C. How long it will take to compute? And that's where you need computing power. And the computing power is enormous right now, so that it can go and compute so many things. Whatever is available, whatever you feed the data, entry person feed the data, or a data scientist feed the data, or engineer feeds the data, it will compute. So that's where the computing is very important here. And keep that computing aside. What is the other one important right now, which was not there, which was there but very little between 1997 and 2017? It's data storage. Data storage. So, in 1997, we had a storage of 1 GB or a 2 GB or a 10 GB, or it's like that only. It's very expensive, to have a data storage. But right now we are talking about petabyte, exabyte, thousands of GBs, thousands of petabyte, and all the stuff. Why it is so? Because the storage devices, there are a lot of innovation in storage devices that made the storage to go very cheap, and people can afford to buy 1 TB of storage on an iPhone. Think about it. Imagine, 1 TB of storage not at all available. If it was available, it will be like a millions of dollars in 2000 time frame. But right now, it's all changed. You can have a 1 TB of storage on your mobile phone. So that's how the things transformed. So I mentioned two things about it. One is compute, and the other one is data. These two things are very important for AIoT. Just map it, think about it, the mapping, the computing, with the CPU and GPU and data storage. You got to have, the storage, many fast storage, like, so many SSD and SSAs and many storage types are available to speed up, the read and write of data into the storage. So these two things directly connected with the AIoT. Can somebody explain to me on that? This is like a kind of interactive, so that you'll all learn about it, because these are all very important. When you understand the fundamentals, you can solve the problem easily. So can somebody talk about AIoT, artificial intelligence of things? That is nothing but AI plus IoT. So how that is related with the compute and storage? Okay, very quiet. So maybe let me. Yeah, Indu.
Yeah, we are going to connect a lot of devices together through IoT. Right? And so, if the computing power is more and the storage capacity is more, so we could connect a lot of devices together, and also the machine can learn from the data that is available.
So the connect the devices together. That very good. Thank you, Indu, for stepping, coming forward and communicating here. It's very important, because connecting the data, connecting the devices. Yes, when you connect the devices, you get, obviously there are a lot of sensors will be added to it, and that will receive the data. Sensors means, you when you have a sensor, like a multiple sensors, temperature monitoring, or any kind of sensors, speed monitoring, you will get a data, right? Or a kind of a like a image, like if you take a photograph in a traffic signal or something, the data will be collected, right? Where the data will, or CCTV, where the data is going to go is the storage. It's going to be finally in your 1 TB or 100 TB or 1,000 TB of storage. So you need a storage there. Once you put a data, once you put a data in the storage, you got to do some work on that, right? Otherwise, the storage is going to become obsolete. That is where the work requires compute. You need to do a compute. What is it you are going to do with the data? The data, like, you can do multiple things. You can read and write the data. You can read the data. You can process the data, and you can put the data back to the storage and all the stuff. But when you read and then process it, that means, what is that operation? What you're doing there, you will do some kind of algorithm, so that you can do a learning of the data, what data it is, and all the stuff. That's where the machine learning and deep learning, the part of AI, comes into the picture, and that's why we call it AIoT. when you apply AI into the IoT devices with the data, is AIoT. I hope you understand what I'm trying to say here. I started from 1997 system, 2017 Summit Sierra system, but now connecting these two, the things, IoT and AI, and it's called AIoT. Let me show the, my PPT, I'm going to I'm going to discuss with you a lot of things, and also one of my mentee. I've been mentoring him for the last few years. He's also going to be sharing some key case studies which we are developing as we speak. So let me see. Let me open up my PPT right now. I hope you guys are following, but these are all very important for building, use cases and building the future for you. Okay, so AIoT and its applications, and that's where I'm going to discuss a few minutes right now with you all, and also with case studies. And one of my mentee is going to come and present about his experience on developing a device, AIoT device, and that's where we are spending a lot of time on it. There are a lot of activities going on around the world. Like, nearly we are connected with the 30, 35 countries, getting all these great scientists and getting involved in our, the open source, the open power core, the processor, and trying to see what all the various things, we can add as part of that, so that we can build our own system on a chip. And we can use it for, the purpose. So the introduction, the IoT, you all know about it, basic things of IoT, but how do we put them in use? And that's where I'm actually trying to communicate here. IoT is transforming how we interact with devices. According to Cisco, IoT generates an average of 5 exabytes of data daily. Think about it. I said something, a storage and a compute. Cisco is a top, one of the top networking company. It has been there for last 30 years, and they came out with a kind of a statement saying the IoT devices. When you talk about IoT devices, is basically Raspberry Pi or or any kind of small embedded device with the sensors, and even the CCTV generates an average of the 5 exabytes. How much it is? We're talking about uh, gigabytes and terabytes and exabytes. I was telling about, I have a 1 TB of the iPhone available. We are right now 1 TB. So 1000 TB equal to is a petabyte, and then 1000 petabyte equal to exabyte. We are talking about 5 exabytes of storage of of data daily. The IoT generates. Where it is getting stored, that's where the right now the storage is. So the storage technology has been developed very well. So it's available, for like a kind of one can easily buy that, and with that we got to use the data to basically develop the business. If a businessman wants to do something with that, he should be developing using the data whatever available, and that's a main goal of the AIoT kind of important area where people will spend time on it going forward. So the three IoT empowering technologies. So, as you see in the slide deck here, artificial intelligence, we talked about it. The artificial applying machine learning, deep learning kind of ideas with the data, you can make the data more powerful, robust, and highly performing, and maybe the data you can make money out of that. That is one thing. And then 5G, the network is very important, right? The data has to be pushed from one location to another location. We need a kind of a good networking, and the 5G provides that kind of thing. And then the big data. The big data is basically kind of, when you have a exabyte of data in a storage, how do you read and write the data, and how do you apply AI kind of capabilities, to transform the data into kind of the business opportunities. And these are the three things, which one should know about it, and go for it. And as I said before, a smart connected network of devices that seamlessly connect over 5G networks. So the data will be connected, a connected network of devices that seamlessly connect over 5G networks. And that's where, the smart, how the data will become smart, applying AI. And that's where, we call it, the overall, the AIoT. And you see here, this is the kind of an architecture put together by one of the scientists, and how the world transformed right now. So we talked about neural and fuzzy system 1980, 90 and all. So you see a rule-based expert system around the time. Not much systems available during the time, not much storage available during the time. And the neural and fuzzy system, with the limited data what we had, we were able to do some prediction and all this stuff. But it's not that what we are doing today. And then CNN and deep neural networks. So convolutional neural network and deep learning, deep neural network, these are all the things applied to the GPU kind of devices, and speed up the process, and getting some kind of result out of that. And then now we are doing about autonomous learning networks. What does it mean, autonomous? You put a chip along with the IoT on a network cable, and automatically, the autonomously, the chip will learn what kind of data it is. Based on the data, it will take the action also. And that's what we are trying to communicate here. How the processor also here, we saw call it the RISC-V. It is also one of the open source processors similar to open power. And these two processors are under open Linux foundation, and available for people to start using it. So this is where, you need to focus on. So developing a device, and developing a device using AI and IoT kind of capabilities. So look at this, the rule-based expert system, neural and fuzzy system. This is where, even the deep blue, what we did in 1997, we used that. And then in 2010, the CNN and deep neural networks, like a Watson kind of supercomputer, evolved after that. And then autonomous learning networks is a Tesla kind of a car, also operates using that kind of the autonomous learning. So self, I mean, driverless car, and the autopilot, like so many things, we have example for that. So major IoT segments, like you see that wearables is a very important thing. Every day, you may have a watch, to track your fitness. What are the things it tracks? Number of steps you walk, and many other things. Now the fitness tracker only will help you, to build your, ecosystem, for healthy ecosystem very well. And how that is being done. Basically, there is a sensor attached to this watch, and also, there are like a kind of a the GPS kind of a location based tracker also included there. Using that, it will track how long you walked, and how much calories you burned. All those things, it will basically learn from you for many days, and then it will also guide you to follow the steps, so that you can maintain a proper, a good healthy health. I mean, using that, and that requires a lot of background work too. It has got it, the fitness tracker. I mean, the wearable watch connects to the cloud and do a lot of processing there. It doesn't do it in a watch, in your watch. Not much computing will happen in your watch other than probably a simple calculation and all, like a calculator. So that's called edge device. We call it edge device connecting to the cloud. We will be talking about that in our next, I mean, during our case study. And then smart homes. So smart speakers, IoT appliances. Give me an example of what is lately available from Amazon or Apple or Google at home. Can you all can somebody talk about it? We call it smart homes, right? What is it? What is like smart speakers and IoT appliances? There are few famous things available through Amazon, through which you can do a lot of activities at home.
Is it Alexa?
Yes, thank you for. I think this is very important. Interaction is very important. The Alexa, go and start looking at how they would have built Alexa, or maybe there are a lot of open source documents and even the codes available to build a feature called Alexa kind of a system, or a Google Home kind of a system, or a Siri kind of a system. So the Siri is from Apple, Google Home from Google, and Alexa from Amazon. Like that, IBM built many years ago Watson Studio and so many featured thing, but we did not get into the consumer market. We wanted to facilitate and work with the enterprises, so we are limiting our scope with that. But the Watson was the first one to build this kind of the equipments and all, like in 2014 2013 time frame. And um, and look at that Alexa, how that has been built, and also like the Google Home. There are some open source components already available. You can look at it. It's basically kind of a cloud, and the data will be stored in the cloud, and also the most of the computing can happen in cloud. And on the edge, there are things which could be computed, and inferencing also will be done. It's basically the voice recognition and all happens locally, and then it will immediately do the processing and get back to you with the results. And that's a kind of a story, a separate case study we can have too. And then similar to that, like the smart cities. There are so many AIoT segments coming up in the industry. I mean, in the world right now. Smart transportation, energy grids, smart street lights, and then smart industries, robotic manufacturing. So even we are talking about in future metaverse kind of the XR, extended reality. That means virtual as well as the augmented reality, including to the it's called XR, the extended reality, and where you'll have lots of virtual reality things will come in. It's all AR, VR, all through the deep learning kind of the segment only. And the other thing is digital twin. I hope you heard about that. It's basically, if you can look up in the Google, like we developed using our Watson system. We developed a lot of digital twins where in a manufacturing unit we developed something, kind of a smart tool. It's a kind of uh, the uh, working instrument. Similar to that, we'll have another instrument that will simulate kind of another working instrument. Using that, we do all kinds of the testing, and kind of any kind of activities we do with that. And using that, we basically perform lots of activities, not on the production but on the testing side. Like that, many digital twins IBM developed in the industries for them to basically do a lot of autonomous things. and these are all the things is all happening in industry 4.0 kind of a segment. So wearables, smart homes, smart cities, and smart industries. So in this slide deck, you know everything, the stack, the complete stack we have as part of AIoT is basically AIoT based system for real time monitoring of tunnel construction. So like this kind of example for each and every case study, one can put together. And then in the top you see here there are like prediction you can do, and then offline training you can do, like I said about the digital twin, right? Like that, you can do things, when the thing when actual things are not running also, you can simulate simultaneously. So like for each and every like use case, we'll have a case study. I mean, we'll have a kind of a stack, from the perception layer to application layer. A stack, one has to put together and then design the complete system. And this is how the things are moving forward too. And then emerging AIoT applications. So definitely, this AIoT is playing a big role in medical area. There are lots of use cases that are there in medical area, and healthcare monitoring, like and the genomics analysis and all. And then many other areas where the AIoT could be applied quickly, and and it could help the society also. So this is a small list, whatever I have here. And many use cases, already people are developing, using this, because of the computing power is available, and also the storage capacity is also reachable. Okay. And like this is actually kind of uh, summary about the AIoT, how one can do and all. Now we are going to look at some use cases with the team. Like I have a person, Venkatesh. You joined the call, Venkatesh.
Yeah, hi Ganeshan. Yeah, I'm there.
Oh, okay. Oh, you're there. Okay. Thanks for joining. So I have a
Yeah.
mentee, who has been working with us for last 2 years, and now he's working for a startup in Bangalore, and he basically has been using our processor, the Open Power Core processor, and trying to build some of the cool devices, as part of the innovation. And I'd like to welcome Venkatesh to share the case study, whatever he has been working with IBM and Open Power Foundation team. Venkatesh, please go ahead.
Yeah, thank you so much. And good afternoon,
I just opened up the presentation for you. Like you can
everyone.
share the
I'm
slide deck
Venkatesh.
if you have.
Yeah.
Looks good, Venkatesh. Can you hear me?
My screen is sharing for everyone.
Yeah, looks good. Go ahead.
Yeah. And hi everyone, I'm Venkatesh. Actually, this Open Book Foundation is a very good platform which provides an ample of opportunities to students, industrialists, and also research scholars, and like to upgrade the skill set depending upon the technology evolution, and can also have good exposure to the cutting edge technologies and industry standard tools through this open for ecosystem. Let me give you a brief about what are the topics. And first AIoT, using these open power cores and open power processors A2O and A2I. We are developing an SOC. Based on that, we are dumping into an FPGA and we are using those into a cloud. And how it will be and what are the case study. Let me brief about the what all the things we have done. So let me know your power architecture format, how it would be, like what are the power ISO we are using there, and what the versions we have, how many specs we have for and books we have referred for open power ISA and ISA compliances also, and AIoT, those advancements and how we have moved to that, and what are the benefits and case study. Our power is a timeline power optimization with enhanced risk. ISA timeline sen. Earlier in 1990, we have Power PCs appliances, formed a lot of embedded and Power PCs of form for developing a server side and also in process develop. And in 1997, a need for creating a separate version of Power ISA, specifically targeted for embedded PC evolved, and there have been two threads running from 1997. ISA evolving in parallel in 2006 timeline, but those got merged in one of the version in 2006 timeline, and in 2.03, these first version was serviced and embedded side got merged into a single definition. After that, we have gotten 2.07 version from which a single version of 3.0 has been evolved. At present, we are at a 3.1 version that uses Power ISA, MMA like matrix math accelerations and prefix instruction support and SIMD architectures and all the next gen supportives. And coming to in 1957, its instruction set is not compatible to all of the ISAs, but it has a full set of Power ISA and full architecture compliances. So there can be a certain levels of compliance as a part of an Power ISA, like a decimal float for like any of the floating purposes, SIMD architectures. We have three books which have been referred for power architecture formats. Like book one, user instruction set architecture. It has facilities supported for memory reference, flow control, integer, floating point, and numeric accelerations. And that it works on an environment like an application level programming model, generally a compiler generated. And in book two, we have a virtual environment architecture, storage model for thread and resource interaction, like time synchronization, cache management, storage features. That would be generally an assembler generated and a non-privileged library level programming model. And book three, operating environment architecture, supervisor instructions and related facilities, exceptions, interrupts, memory management, debug facilities, and special control or resources. We have here supervisor, hypervisor programming model in book 3. These book 3 and like a ISA version of 3.1 have been utilized for open core process like A2O and A2I developing purpose. These power ISA compliancy subsets have many of the four subsets that can be chosen among these. It can be a scalar fixed subset, fixed to point subset, and scalar fixed to point and floating point subset, a Linux support or AIX support. A full 3.1 version has all the instructions, 1419 instructions that are compatible of all the instructions. And a support base architecture that would be a never optional one. Here we are using a full architecture compliance of Power ISA 3.1. And we may utilize this for the combination of an hardware and firmware in order to reduce to get a more functionality, to have a more supervising functionality. And it can include any of the following features of the sets above, like SFS or SFFS or Linux subset or AIX subset. These are compliancy subsets which we are using. And here we have laid a foundation for 3.1 Power ISA full version. It has like SIMD architectures for 32-byte access operations, or maybe an class operations like bit manipulation operations, or virtualization load or store rightmost element operations, or like mask manipulation operations, or maybe a generate operations for expand or compress. They're all like extensions of a hypervisor interrupt location control, and an instruction prefix support of 88 and modifying opcodes also there. These would support a risk-friendly one, variable length instructions of an 8 bytes of instruction space lays for the foundation for future of an ISA expansion using the 3-point ISA. And we have like modifying an opcode and MEA lane masking and additional instructions capabilities that would generally let founders for expansion of or including opcode space and additional modifiers also. That's a brief about our ISAs and what how we have come for an ISA 3.1. AIoT, like artificial intelligence of things, it's a combination of an IoT and an AI. Like IoT enables a network of physical objects that are equipped with sensors, software, and other technologies to exchange data with other devices and systems over the internet, and an AI that enables data analytics and automated decision making. Obviously, you might have look about of all the IoT devices that are working now, like smart watches or maybe any of the devices that are working through like data debugging from one location to the another over the internet working over. So there may be huge data that would be running through over the internet that becomes a hectic for the data deciders to take any one of the data. At the time, we need an AI capabilities that would be very good in order to decide which would be a better data to analyze, and maybe like that data would be used for another purposes. And also we have some IoT devices like using moreover the technologies that the technology has been advancing by day. Why we are going for an AIoT instead of an IoT? In that way, in that purpose, if you check on, it has many like applications regarding in real-time analysis of data, and also it helps in immediate taking action, whether which data need to be modified or more formed, or maybe encryption of the data in that perspective at the time of when security issues. And what are the benefits of an AIoT? We have a real-time operational decision making. See, earlier we have an IoT devices that would be using, for example, like camera. That camera would be detecting all the recording all the things which have been going on. If your any enemies in case of an army utilizes, in case of an enemy is trespassing, at the time it would be only detecting that, but it can't alarm us, it can't make us an attentive purpose. There should be any other like alternative employee to you need to check on that. So for that purpose it would be very hectic in that way if many data is like large data amount of data is being getting. So at that time AI plays a major role. So by using an AIoT camera, it can detect, and that also gives some type of an alarms which you have been implemented in it in order for taking a decision making from human security personnel to an IoT device. And also it would be reducing an labor costs also, that would be an if we have automated for that purpose. At the time of a real-time operational decision making, it would be very helpful for very helpful and continually improved decisions. And we have like smart home nowadays, everyone is equipped with a smart home. It will be very improving the machine learning models also, and it will be very preferences for the improve of decisions also in order to having an AI IoT. And I think we have like Sophia, which have been an AI robot that have been implemented. So it takes an own decisions depending upon that. So there will be an AI which uses an data analytics and neural networks and machine learning. Based on these features, all the decision would be taken, and also data would be analyzed and collected based on the differentiated how it would be, and also to have and reduce data transfer costs also, and decreasing the cost of a CPU and memory and storage. and convergence of an IT and operational technology. It would reduce the like labor charges, and also in technology that would have a very interaction between encryption of and data also if any of the data corruption takes place at that time. And we have some IoT use cases like smart cities, um, energy distributions, and also an energy consumptions in the, and also like traffic management at the time we can use, and also like waste management in that way, and smart homes. And nowadays we have an like voice assist that would be controlled by using an natural language processing NLP. Those capable have been involved in an voice assist like Alexa. That would be helpful in reducing the power or energy, and also in reducing all the effort, um, power, and also in cost and labor costs also. And at the time, and in industrial internet of things, it would be very helpful at the time of as a technology that connects people, products, and process to achieve the digital transformation for industrial businesses. And through these industrial internet of things, it would be a very complex process such as manufacturing be reshaped by leveraging a data at the time. So we use an AIoT systems, including visions of like camera and also computer vision to model a usual check for quality defects, or maybe any of the defects that have been used in that at the time of checking the quality or testing. And then autonomous things, at the time of delivering of robots, and like Sophia only, it would be very autonomous thing. It can have many capabilities. It can take decisions, and also drones and automated vehicles. Tesla, I think Tesla has been implemented an automated electric vehicle using an AI. And wearable devices like smartwatches, and like a smart detection at the time of in sports also, like monitoring purposes. If any of the data has not been collected through the observation of athletes, or maybe using a sensors, it would be using collected, and it would take, and decision will be taken, and leveraging data visualization as well. And coming to a case study using this AIoT, we are developing Anant, a fabless SoC using open power processor A2O, which has many capabilities of SIMD, virtualization, MMAs, SFX, superscalar sets. In that way, we have been developing that fabless SoC. After developing the fabless SoC, we are porting it to an FPGA. This FPGA porting can be done by using Xilinx, or maybe on boards which have been available for Xilinx, like Zinc boards that would be used for porting, like dumping of that fabless SoC into an FPGA porting will be that Zinc boards. And after FPGA dumping, we need to convert it to a cloud. We need to upload it to a cloud. Like the designing and all the application has been completed here, and debugging in FPGA has been done, and we will verify whether it's correct or whether it is correct or not. In that way, the testing would be done, and resulting the hardware application is both maybe a vendor and a device dependent also. So at the time of when developing an FPGA based hardware application, it will be still restricted to hardware designers only. So by using a virtualization, we would be dumping into a cloud enables the integration of an FPGAs with computing infrastructure such as in data centers and clouds. And this FPGA virtualization platform that enables any application hardware to be ported on an FPGA and accessed as a standalone custom computing machine as a CMM. So this introduces the CMM services for that. And a prototype of the virtualization platform has been implemented to evaluate its speed and power and area and all the overheads it has been taking up. And with the comparison of other platforms, with also proposed platform providers and also in general interfacing of any design that would be taken and will be comparable with the overhead that will be taken on notable on platforms that where we are doing an experimental results in that way and using a streamed application in a cloud-like environment um, that have a very viable like computing option in terms of an like throughput latencies and for applications compared to an conventional server based or virtual machine based software implementations in that purpose. After that, it will be by using a server we are able to um, control or maybe collected data at the client location or maybe any other data centers where you want. Here we will be implementing some sensors like FPGA that actually this Anand has some SPI, I2C, PCIe and DMA, NAND and NOR flash memories. By this I2C, SPI, and there are some sensors that would be supported like pressure, humidity, temperature. All these sensors will be collecting a data, and that would be sent to a cloud. From the cloud, we are gonna get it from our client side or maybe and through we can operate at anywhere else. It can be connected to any other mobile phones also like smart devices that would be used at the time. So this is a power pack, the combination that would be very helpful in the coming generations. Like also like a AI, what it would be very helpful in terms of in data deciding and deciding factors of another thing like data deciding factors only. The near future like smart cities, smart watches, and smart wearables and all the smart devices have been evolving up surely that the coming smart devices would be having capable of AI IoT also. That capabilities will be incorporated. Maybe in the future, the companies would be looking into it. Already, mostly the companies are looking forward for an AI IoT. That would be a very advancing and evolving technology nowadays in order to reduce the labor cost and also energy consumptions and also used in various fields, not only in the like a medical field and our technology side fields at maybe in farming, agricultural IoT. There is there by using those many different areas we are using these smart devices which are linked to an IoT over internet that would be used and many use cases out there. This is one of the case study what we have been developing far through. Thank you.
Venkatesh, thank you, Venkatesh, for the wonderful detail about how IBM's open power core getting involved with the AOT kind of devices. So this is how one can use the IBM the processor and build the AOT devices. And there are a lot of work going on with our partners uh, to build the cyber security um, featured devices and and high performance computing supercomputers one can build with that, and then the AI kind of platform one can build with that. The processor, what Venkatesh mentioned about it, the A2O, A2I, and the microwatt cores. There are three cores available, like which are available for several the research people as well as the professor faculties and many other developers can make use of that. So, any questions on Venkatesh? The presentation so far and my presentation, so that I can move on to a next level of uh, a case study, which may be very helpful to many people in the society too. There are a lot of people have been working on that, but we are trying to see how we can make that one reachable to many villages too. Any questions? Okay, so let me move on to the next one. I have okay, let me see how I can share this. Okay. Okay, so diabetic retinopathy using AI Jetson Nano. So can somebody explain to me, like, anybody develop these kind of devices, or anyone in this team of people worked on a Jetson Nano device? Jetson Nano device is a kind of a edge device, can be built using open power kind of a chip also. So NVIDIA, our partner company, already built a device which you can put it in your palm and take anywhere in the world, and kind of the palm device. Using that, like, you can do a lot of wonders. So anybody knows about it, the Jetson Nano device in this pool of people? Okay, these kind of devices also can be developed using IBM Open Power Core, where Venkatesh mentioned about the CPU core, and you can put that on FPGA, right? The same thing, similar thing, NVIDIA did it uh, a couple of years ago, and this has been used for many kind of the edge kind of activities, edge device, where the the data are coming. You can keep the device, and the device can take the data and do the inferencing immediately. So I'm going to walk you through several steps through which one can design and develop a AOT device for diabetic retinopathy. So let me go through that. So right now, the use case. What is that use case? I already explained to you. Diabetic retinopathy is a field to diagnose the level of diabetes based on the retina image. In all, there could be 5 categories of diabetes in total. So this is a domain skill. Like, basically, we got the details from the doctor, and basically, these are kind of information. We worked with a couple of hospitals in India, and we got some information on that. And then zero means the no diabetic retinopathy, or one means mild, two moderate, three severe, and four proliferative DR. So that means it's uncontrollable. So it could be possible we need to make this happen in a remote areas, or where doctors are not available to diagnose the disease. So the goal we had initially is to give this kind of devices in the villages where the doctors or hospitals are not nearby. They have to go, you know, in kilometers, to go and get treated. Instead, they can have this kind of device in a kind of a camp or something, and they can get it tested, and uh, get some initial level of uh, result there. And then the system could be ported in some mobile device, or get connected to a medical device. To the device could live picture, and system could correctly identify the diabetic level based on the retina image, completely offline. So it need not have to have even the network also available. It's basically we have a inferencing already built, inferencing engine. That's what I'm going to talk about it. And using that, you can load it in a mobile phone, or you can you can also put it in a just a nano kind of device, and then get a image from the consumer, from the people who wanted to test whether they have a DR or not. And immediately it can give a result, like the five numbers, 0 to 4. So that's how we started this experience, the work experience, 2 years back, working with a hospital in India. And the solution provided. So we got from the hospital 35,000 images. You see here, We got a lot of images. We need to have a storage to store the images too, and high resolution images, which are labeled under 5 categories: 0, 1, 2, 3, 4. You know, there are a lot of radiologists. Do have this kind of images in the hospital. Hello, please go to please go please go to mute. Please go to mute. Please go to mute if you're not talking. Please.
कोई प्रॉब्लम नहीं, हमने भी वही किया था यहाँ पे फोटो सेशन में, सबने एक ही
Hello.
नहीं सर कोई
आपल्याकडे कसं आलं फोटोग्राफर आलता बघा
सर यहाँ फोटो सेशन रखा था, 2-4 ब्लेजर रखे थे और सभी ने वही पेंट करके निकाले खुद का।
Madhuri, can you go to mute?
और कहीं
Madhuri, Madhuri, can you
Madhuri ma'am. Excuse me, Madhuri ma'am. Can you mute your audio?
Okay,
Thank
I
you,
think
ma'am.
she muted. Thank you. Sorry for the inconvenience. Looks like some people started talking without unmuting. I mean, without muting their microphone. Okay, so we need to yeah. So I was telling about 35,000 images we got from the hospital, and and we did our experiment here. So what is that we did? Pre-processing of data happened in which images are rotated to 90, 180, and 270 degrees to make the data set more accurate for training. Extended data set as around 1 lakh images. So 100,000 images we got by extending the images by rotation. And deep learning algorithm has been created on Power 9 IBM platform, and data is now ported to Power 9 system for training, and training is done using 4 Tesla V100 GPUs. So already I told you about the supercomputer Summit and Sierra. That kind of supercomputer we use to train the data here. It could be 1 lakh or it could be 1 million data also. That can be trained easily with the system whatever we have. Once the training for completed, once the training is completed, it generates a model as an output. So using the deep learning algorithm, we completed the training, and then it created a model. And generator model could be ported on any commodity device. That's where we are talking about just a nano or a mobile phone or any other a small device or any other device based on OS such as just a nano. Alternatively, model could be deployed on a cloud service which could inference from local system by uploading the image to. So many ways you can expand this the idea and help out the customer. And we made it like that, and then the retina image capturing device captures the image and sends the image to a cloud or a local device which runs the model. It also sends images with a making label to Power 9 system, which will further enhance the model based on new images. If the retina capturing device is a portable device working in a remote area without any internet connectivity, we can design a new device to adapt the model on the hardware and do inferencing on new images captured offline. So there's several things one can do with that, and even we can also create a new device and a flexible new device. It could be a AIoT kind of a device, and can do some additional work also as part of that. So this is the solution, the overall. So how it works? See here the flow. The flow chart is very important here, and we are actually basically similar to this kind of solution. You can apply to many other solutions too. So number one, look at it. Diabetic retinopathy high resolution labeled image set. That means what? The 35,000 images, whatever we got from the hospital, we have to label according to the image, the image status 0, 1, 2, 3, 4. Like that, the images have been labeled, and then the second, image pre-processing and data augmentation. So the image will be pre-processed and then the data augmentation. The data will get, we will get more data also. It's not just limited to, the hospitals given, once we have the system running, we can also collect new data, right? I mean, new images for testing. That image also can be augmented with the existing data sets. And that's what, we are doing it here. And then we are training the images with the deep learning model which we developed it internally. And the model is we have been the training takes depending on number of CPUs, number of GPUs, but also the number of data. The training takes time also. If you use only the CPU, it will take a lot of time because it is not meant for only the CPU kind of processing. It requires a GPU kind of the parallel computing kind of a feature, and that will help you to speed up the whole process here, and it will quickly generate the model. And then the sixth is retina image capturing device. So that means what, you got the doctor's office, you may have a retina image capturing device which will keep on feeding the data to the number one. And then fifth, okay, sorry, we have to go in this direction actually. The trained model. Once the system creates a model, you will have a trained model available, and with the trained model, the inferencing output from the trained model on the Jetson Nano. Whatever the model we train using the system, we will be exporting that into a Jetson Nano kind of a device, RF mobile phone kind of a device. Using that, people, basically, the retina image, whatever we get immediately through the capturing device or a phone or something from a camera, uh, that will evaluate immediately and give the result. And this is how the whole the process done, for the diabetic retinopathy using the AI. And it's a kind of combination of artificial intelligence and IoT here, where we are talking about IoT here. Multiple images you will keep on getting from the image capturing device, and that's where the IoT with the camera and all the stuff. And then where the AI is happening here. Number three, the Power 9 system model training, and then number five, inferencing output. In these two places, the ML and DL kind of a program is running there, and that's where it will go and basically compare the data and immediately come out with a result. And the number three and number five requires a lot of AI capabilities, and number six require the IoT kind of the device capability, and these all put together a solution which is available in some hospitals where you can speed up the whole retinopathy, the diabetic predictions and all. And we have a code already open source, the code whatever we developed, and this is where uh, we have developed, and we uploaded them in GitHub. You can take a look at it. One of our employees from IBM, Arshad Mahamad, he basically worked on that, and he uploaded the all the code and everything, so that other users also can get it, and and get that optimized also. The model is trained till 50 epochs to get around 97% accuracy. So that means it's a good accuracy one can get with that. But it doesn't mean that you're not, if this program says you don't have a retinopathy diabetes or something, it doesn't mean that you will not get it. But you have to keep on testing it, and if there is a question or anything, you should consult a doctor for that. 100% you cannot just believe that the one whatever we are providing, but this is a kind of addition, in addition to what you have, you can check it at home, and if there is a problem or something, you have to go and consult a doctor actually. And this is how this is written, and we have a system also available in University of Oregon. Using that, you can run this model with 1 lakh images, and get the model out of the system and put it in a just a nano what you have at your home or even a mobile phone. If you develop an app to run a model, I mean to do a inferencing, you can do that. And this is how we as a team of people worked on this and and made this AOT possible right now. And similarly, there are a lot of case studies people are working on it, hundreds of thousands of case studies, and they're all put, getting used by customers right now in the banks and in the in the manufacturing places and in police stations, and I would say many places. Even there is another use case also. We started working with another customer for vehicle security. Um, it's basically another use case where you see here the purpose of I'm going to just define you, help you out. What is that AI based security management. So the objective of the whole process here is safety and security of a vehicle is of prime most importance for the owner and to an organization, right? So entry of an authorized person vehicle inside the premise is one aspect of security. Employee level entry in an organization is restricted by RFID technology. Monitoring, controlling, and security of vehicle needs better mechanism. We need to ensure that the authorized employee with their own vehicle should be able to enter the premise. Equipping a smart system which helps identifying the authorized employees and their vehicle is necessary to operate the vehicle's security system with the maximum security and efficiency. And that's the goal of this, the overall the AI based security system at your parking lot. So the solution what our team is planning to provide is to develop an AI-based model to detect the numbers in the number plate. You think about it, in your car or in your two-wheeler, yeah, we are actually working on. It's basically there may be a lot of solutions available, but this is for a particular customer. In parallel, the model should also be able to recognize the face of the person sitting inside the car. The whole model could be deployed in just a nano, an edge device to which a camera is attached to capture the footage. The complete setup would act as a CCTV camera. The system would match the number plate and the person driving the car. If the person in the car number matches with that number of plate in the records, system will give a green signal and allow to enter. And that's a plan we have. And this is the kind of requirement we got it from a customer, and we are working with the partner to get this done with the IBM system and the NVIDIA Jetson Nano kind of a device. So offline, you can also go through that. And if somebody wants to work on these kind of projects, we have got like at least 20-25 projects like this. If somebody wants to work on this project, please do let us know. We can work on a very good plan on this. And then this is one of the use cases which I wanted to share. And also this is not it. We also have a lot of training programs. And this year the mission is to build many training programs for enabling students, faculties, and researchers worldwide using our the IBM open power technology. And the agenda for the program is here where we will teach you everything. We can't do it within 1 hour and all. It takes like 6 hours to 60 hours program. And we do have curriculum on this, like a workflow of machine learning, use cases of AI, hardware implementation of neural network models, AI in IoT. This where one can build their own just a nano kind of a device. That's where we are teaching that also. Components of IoT, building IoT application, and a complete case study implementing AI in IoT. And all 6 topics would take like starting from 10 hours to 30 hours with the practicals and with the systems. We run the workshops too. We are planning to run these workshops starting from next month. If anybody is interested, do reach me out. And certainly we have team of people who are available to do this kind of stuff. And it's not just IBM, it's me, and my, the technical expert, and also the teams from, Germany, and, our partners place, Oracle, and, Tata Research and Industry SME. Like that, many team members, working with us, to build, these kind of systems, um, on the with a planned approach. And due to this COVID and other stuff, we are planning to do it using the Zoom call only. But there are cases where we give a remote Jetson Nano device access to go and do some activities on that. You will have a lab also. There are a lot of cloud. We set it up worldwide. Using that, we can connect, and we can do the training, model training, and model exploitation, and the model inferencing using Jetson Nano kind of device. With this, I'd like to conclude my session here. And are there any questions?
Yes, Ganesh, I have a question.
Yeah, go ahead, please.
After deployment of the model, like you told that the model will be again trained with the new images, right? With the new images that is coming for testing purpose.
Yeah,
So
it is a
how it is trained again, and
it's a kind of a batch process in a
okay, like
in a
okay, you
computer.
have a frequency. Uh,
Once in a week or something, put it in a batch mode, with the new images, with the existing old images, you can train the model. And it takes a lot of time, and the images will grow also significantly. And that's where all these GPUs put in use, and that's where
so
all
it
these
has to be
supercomputers
again
also going.
deployed back.
Yes, a new
Okay,
model will be deployed in the Jetson Nano.
okay, okay. So it is done as a batch process.
Yeah, good question. I think, I'm like, you got all the ingredients as part of this AOT talk. Thank you, Indu. Which college you are from, Indu?
Thank you. Amrita College of Engineering and Technology, Nagarpur.
Oh, okay. Sure. Reach me out, if you have any further question or anything. I'm going
Sure,
to leave my
sure, sure.
email ID somewhere here. Hold on.
Okay.
Is there a
Yeah,
Yeah,
thank you.
you all can reach me out if there are any other things you need. And we have specialized workshops in AIoT, the short term and a long term workshop where one can go and run a case study. And also, this is also applicable for students and quantum computing also. We have been, pioneered in quantum computing, and we have access to our quantum, and also, like, the various things around the quantum too. And and there are a lot of other key things one can work on to become technology expert, like a cyber security, and then the hybrid cloud, and you know accelerated computing, the GPU level things, and like that, many areas people can go and explore skills. And this is a great opportunity for you guys, uh, to upgrade your skills so that the faculties can write papers, or present in international conference, or develop some solution working with the industries. And even the Indian government inviting for I think chip to startup or something kind of program where you can you can actually propose some solution and get some funding and work on make in India kind of a chip using our open power core. We are here to help you out also on that. So the many advantages one can get with our the complete silicon to application stack. Okay. Any other questions?
Like,
Hold on.
is it
I think
possible
I
to create like ID on for using Power 9 as a researcher?
yes,
Like, we can just go and log in and
yes.
use.
Yeah, yeah, reach me out, and we will. I'll see
Sure,
how we can collaborate going forward on
sure,
that.
sure, Ganesh.
Yeah, there are a lot
Thanks
of
a lot.
technology. Yeah, there are a lot of technologies that are there. Like that's what I'm saying. From silicon to the application, silicon in the sense I'm talking about chip, and then the motherboard, and then the system, firmware, operating system, and application. When you talk about application, the AI comes to picture. But even at the chip level, also, one can add instruction uh, based on what the need, what you have. Like a linear algebra is being used for a lot of machine learning applications, right? We have used the linear algebra, one of the linear algebra feature called matrix multiplication in our chip level. And uh, right now, matrix multiplication, easily you can get it done, even if it is a massive multiplication within a fraction of second, by using our the commands. So like that, people can think about, even the cyber security side, any other encryption idea, like, which you can add it as a part of an instruction set, so that from silicon to the application, you will have control over it.
Okay.
Any other questions? I have just shared my email ID, and also, like, maybe you can some people can take my WhatsApp number also. If there are any things, you can reach me out. I'm leaving my US WhatsApp number, and see how you can reach me, and get yourself knowledgeable in in the technology, whatever I have been um, working with customers. Okay. Okay, with this, I'm closing my session. Thanks a lot, team, for being with me for last 1.5 hours, and I really appreciate it. And I will share the material, uh, to the organizers, so that they can circulate to you all. Okay, okay then. Thank you very much.
Thank you, sir.
Thank you.